Ever looked at a sine wave and thought, cute wiggles, but why so extra? Good news! We can compress it into one slightly less unfriendly complex number. Our star is x of t equals a sine over omega t plus phi. A is the magnitude, omega is the angular frequency in radians per second, and phi is the phase. In AC analysis, we use phases to freeze time and do math the easy way. One tiny twist. Phases use cosine as the home base. Since sine of theta equals cosine of theta minus 90 degrees, a sine of omega t plus phi becomes a cosine omega t plus phi minus 90 degrees. That means the phasor is a angle phi minus 90 degrees. Think of sine as fashionably late by 90 seconds. There are two ways to write a phasor. Polar form, a angle phi, which is the magnitude and angle, or rectangular form, real part plus j times imaginary part, where j is your imaginary unit. You can convert them like this. The real part equals a times cosine of phi, and the imaginary part equals a times sine of phi. To go back to the time domain, multiply the phasor by e to the j omega t, and take the real part. If you want to express it as a sine again, add 90 degrees inside the cosine. Quick example. Suppose v of t equals 10 sine of 1000 t plus 90 degrees volts. Shift to the cosine reference. 10 cosine of 1000 t minus 90 degrees, as a phasor in polar form, that's 10 angle negative 60 degrees. In rectangular form, the real part equals 10 times cosine of negative 60 degrees, which is 5. The imaginary part equals 10 times sine of negative 60 degrees, which is negative 8.66. So, the phasor is 5 minus j, 8.66 volts. Back to time. 10 of 1000 t minus 60 degrees, which is the same signal as our original sine version. Now, why bother with phasor? Because adding sinusoids becomes very easy. Consider two signals. x1 equals 5 sine of omega t, and x2 equals 5 sine of omega t plus 90 degrees. In the cosine reference, x of 1 becomes 5 angle 90 degrees, which is 0 minus j5, and x2 becomes 5 minus 0 degrees, which is 5 plus j0. Add them to get 5 minus j5. Convert back to polar form. The magnitude is 5 times the square root of 2, and the angle is negative 45 degrees. So sum is 5 times square root of 2 cosine of omega t minus 45 degrees, or as a sine, 5 times square root of 2 sine of omega t plus 45 degrees. Right. Here is a picture to keep in your head. Imagine a ceiling fan. Spinning the blades is the phasor, a rotating vector of length, a at angle phi. Its shadow on the horizontal axis is what you see over time. A cosine of omega t plus phi. Turn that fan by 90 degrees and you've got sine. Pro tip before we wrap it up. Keep degrees in radians straight. Use two argument arctans, said atan 2, and get the correct angle quadrant. Use polar form for multiplication and division. Use rectangular form for addition and subtraction. And that is how the wiggly sine wave becomes a calm, helpful phasor.